Seventh grade lesson 6.1 is on algebraic expressions, and there's a few things I want to go ahead and dust off some cobwebs about. Remember, an algebraic expression is just an expression that includes an unknown value. An example would be like 10x plus 25. This is an expression. That's an x, by the way, not a times. This is an expression, and we have this unknown value right here. So we can't really do anything to solve it right now. We don't have enough information without another piece of information or without this piece of information. So it's just kind of there waiting for a little more information. But that's what they mean by algebraic expression, is some sort of math expression with at least one unknown value. So the next piece to know about an expression is it's built up of terms, T-E-R-M-S, and they're usually, like, you can have the constant term, like this 25 is a term, and I like to include whatever sign is in front of them in with them as a term. He's a positive 25. That is a term. This being multiplied, terms are added together. So they're part of an expression that are added or subtracted from each other. Well, this one is being multiplied. So that would be a whole term in itself. If it doesn't have a sign in front of it, you can put a positive sign there. If there's no sign, we know it's positive. So those are terms that you would see in an expression. So it's just like the groupings that are either an entire number or the multiplied version of it. Those are terms. And the next refresher is that we can combine those like terms, but we can only combine terms with like kind. So as an example here, this is 25. He's not being multiplied or divided by anything. It's just 25. The only other one in this expression is 18. That's just the number, just the constant number, not being multiplied by anything or divided by anything. So these would be like terms. They're both constants. They don't have anything that's being multiplied by them. So I can go ahead and call them like terms. This is a positive 25, and this is a positive 18. The other like terms that I can put together with each other, but not with these constants, is this has the same variable as this. That means that that unknown number is the same exact unknown number as that one. Now, if it was a different letter being used, then it's not. But if it's the same letter being used, they are saying this is the exact same number. We just don't know it yet. And so those are considered like terms. And so this is 10 times h. Its coefficient is 10. So 10 multiplied by h. I can't add this to the constant because this one is being multiplied by h, so it's some different number. So it's not a like term with that. But these two are like terms with one another. So I'm going to do a different shape for them so our brains can see the difference. So those two are like terms. And I am allowed to add together my like terms. So here, with the 25 and the 18, I can add those together and I would get 43. That is that plus that. And I can also add together my like terms with the same variable being multiplied. So 14 h's and 10 more h's is going to be a positive 24 h's. We still don't know what the final answer is going to be. This is our answer for now. It's the simplified version of combining those like terms. And until somebody says, psst, h is this, then we can't really do much more. So that could be our answer. It could be written that way, or it can be in reverse as long as you take the sign with it. That's a positive 24h, and this is a positive 43. So I just swapped them around. That's okay to do, as long as you're taking the sign that's in front of them with it. All right, so let's look at that first example in our book where Jill and Kyle are getting paid per project that they complete. We'll use those steps. We read it. We underline the question. We circle the information they gave us. We draw a picture if we need to draw it. And then we can try and solve. So here we go. Jill and Kyle get paid per project. Jill is paid a project fee of $25 plus $10 per hour. Kyle is paid a project fee of $18 plus $14 per hour. Write an expression to represent how much a company will pay to hire both to work the same number of hours on a project. How much will they have to pay both of them? So you would add their results together. Circle the information. Jill gets paid project fee of $25 plus $10 per hour. So for every hour, she's getting $10 and then $10 again and then $10 again. I shouldn't have made that go past there. There we go. And then Kyle is paid a fee of $18 plus $14 per hour. Okay, let's draw the picture. We have Jill. We'll give her long hair. She's going to get the $25 right away. And then she's going to get, on top of that, $10 for every hour that she works. So 10 times however many hours she works. H. We don't know. They didn't tell us how many hours. That's all right. Kyle, with his little curly Q hair, they pay him $18 up front. And then they pay him $14 for 1 hour, and then for another hour again, and another hour again. $14 times however many hours he works. And it's the same amount of hours as it said how much will company work, the same number of hours on a project. So they're working on the same project, same number of hours. So we know this number is going to be the same. So I would just add all of that together. So it would be 25 plus 10 times H, however many hours she works, plus Kyle's $18 plus the $14 per every hour that he works. I would combine my like terms just like I did in the previous slide. 25 plus 18 is going to be 43. 10 H's plus 14 H's is going to be 24 H's. The company is going to pay $43 plus $24 times however many hours they end up taking to finish the project. This is your answer. A lot of people have a hard time with this being an answer because we're so used to math having like one answer. It just doesn't always. And in this case, it doesn't because we still are waiting to find out how many hours that's going to take them. And once we know, then we'll plug in how many hours and we'll be able to calculate it. And that's the whole point, is get it to its simplest version so that as soon as they do tell us how many hours it took, we can plug in H and calculate quickly. Instead of trying to plug in H here and then putting it all together, we just got it simplified and ready. The next part of this lesson is that occasionally when you're trying to simplify those expressions, you run into something being multiplied by a variable inside of the parentheses. And so that kind of trips you up a little bit. So this is how you get around it. You'd use distributive property. Now you've seen distributive property being used on and off for the last couple of years, but there may be some cobwebs on it. So I will remind you how to distribute in and then also distribute out again, because sometimes we need it one way and other times we need it another. So the distributive property, to distribute in is that this is saying this is 2 times whatever this sum is going to be. Whatever this all added together is going to be. My problem is I can't add those together right now. I have an unknown piece of information. Well, there's a way to get around that. You can just distribute this 2 times every term inside of the parentheses and it would still be okay. So I'm going to take this 2, I'm going to multiply it times 3x, and that's going to be 6x. 2 times 3 is 6, so 6x. I'm also going to take this positive 2 and multiply it by this positive 4 to get a positive 8. And now I have distributed in. That is distribute in. You just distribute that number that's hanging out outside of here without a sign there. When there's no sign next to the parentheses, that's assumed a multiplication. So that's distribute in. So that's what they cover in there. They also talk about distributing out. We'll use that same simplified expression there to distribute out. So sometimes I need it to be distributed in so I can work with these numbers and simplify an expression. But sometimes I'll get something like this and I want to distribute out. This is handled really similarly to the way you reduce fractions. Same skill, same idea. I'm looking at this coefficient and this number here. Is there a number that can divide evenly into both of those? Sure there is. 2 can divide evenly into both of them. So I'm going to divide 2 out of both of them. So I'm pulling the 2 out, pulling the 2 out. There's 2 there that I just pulled out. 6 divided by 2 is 3. And 8 divided by 2 is 4. And look, it just came right back out to this. So you can take an expression, and sometimes you need it to be able to simplify it. You need to distribute in. Just pass that multiplied number into both terms inside the parentheses, and there I got that. But other times I might have this, and I need it to look like that. So I do, just like when I reduce fractions or simplify fractions, what number divides evenly into both of them? If there is one, other than 1, because 1 won't change it. But if there is a number that divides evenly, in this case it was 2, then divide it out, I should say, and put it on the outside. The 2 came on the outside here. 6 divided by 2 was 3. 8 divided by 2 was 4. So there's some dusting off of cobwebs on how to do the distributive property. Let me show you how it goes into this lesson. So in this first example, they want us to, well, they did it for us, but let me walk you through how they did it. They want us to simplify this expression, and that would mean like combining my like terms. But my issue here is this has to go first, and I don't know what this number is. So this is where that use of the distributive property comes into place. I'm going to go ahead and multiply. Keep in mind too, please, that that is a -3. We start to look at the add and subtract signs, not so much as add and subtract signs, but as the positive or negative for the number that's sitting right there. So this is a -3, and I'm going to multiply it by both terms inside of the parentheses, so I can get rid of those parentheses. It's the trick I can use to get rid of the parentheses. So -3 times 7 is going to give me a -21x. And a -3 times a +8 is going to give me a -24. Now I'm going to look at my like terms from here. The parentheses have cleared out by using distributive property. So that helps me get those out of the way. So I'm going to look at my like terms. I have this constant here, a +5, and this constant here, -24. This isn't like them because he's got an x attached to him as being multiplied. But I can put these together. I have +5 put together with a -24. They went ahead and moved them over. +5, -24 next to each other. We're allowed to move these around as long as we're taking the signs in front of them with us. And that's what they did. And they calculate that to get a -19 plus a -21x. Or it could be written as -19 minus 21x, because adding a negative is the same as subtracting. This is a -21x being put together with a -19. So either of these is the correct way to write it, and that is the current answer. You can't do anything more than that until they tell you what x is. So that's using the distributive property to get to break it down, to get rid of these parentheses so that you can combine your like terms. Let's look at another. Oh no, and there they threw the fractions at us. Oh no, not the fractions. That's okay, that's okay. You can do this. You've got this. All right. So they want us to simplify this expression. This is -9a minus 1/3 of everything that's in here. So again, I'm going to look at this not as 1/3, but I'm going to look at this as -1/3 so that the right things happen with my multiplication through there, so that my signs don't get all messed up. And I'm going to multiply that -1/3 times every term, that one, and that one, inside of the parentheses. And again, look at these in terms of the, instead of add and subtract, these is -3/4, -2/3 a, and a +12. So look at them in terms of their positive or negative, not the add or subtract. Okay, so the first one we're doing is the -1/3 times the -3/4, -1/3 times -3/4. It's a negative times a negative, so we know it's going to be a positive. I'll cross reduce. 1 times 1 is 1, 1 times 4 is 4, and I'm going to get +1/4. Now I'm going to do -1/3 times -2/3 a. That is this times this term here. And I don't have to worry about the a right now because I'm multiplying those together, so that's just going to carry over. And it's a negative times a negative, so it will be a positive. So now I just need to cross reduce if I can, and I cannot. Then multiply straight across. 1 times 2 is 2. 3 times 3 is 9. So I get a positive 2/9 a. That's where that came from there, or that's where that came from there, I should say. Then we're going to multiply the -1/3 times 12. That is a -1/3 times a positive 12. Let's make it 12 over 1. Cross reduce. 3 goes into 3 once. 3 goes into 12 4 times. It's a negative times a positive, so it'll be a negative. 1 times 4 is 4. 1 times 1 is 1. That is the same as negative 4, and that's what they got right there. Now they started moving things around. It looks like, oh, they just went ahead and put that's a plus negative 4, or this negative 4 being put together with it. Your brain gets used to the fact that you don't have to see that plus sign anymore. You just know that these are all being put together all the time. They're just either a positive being put together or a negative being put together. So now let's go ahead and marry the like terms. So the like terms that we have is we have numbers being multiplied by a negative 9a and a positive 2/9 a. And then we have numbers not being multiplied by anything, a positive 1/4 and a negative 4. So I will go ahead and they went ahead and moved those near each other. So they went ahead and took this 1/4, moved it here next to that guy, and they moved this guy over here. They took his signs with them, so it's okay. Now they went ahead and put these together. A negative 9 plus 2/9 a gives you negative 8 and 7/9. And then a positive 1/4 plus a negative 4. So you have negative 4 you owe, and then you get a quarter back. So now you just owe 3 and 3/4. So negative 3 and 3/4. And that's the final answer for now until somebody comes along and says A is this. So that's the steps that they went through for that. And I know it feels a lot more confusing with the fractions there. So if that's feeling confusing with the fractions there, then we practice a few times with whole numbers there to get the hang of it. And then we'll come back towards putting the fractions into it afterwards. So that part just dealt with the distribute in of the distributive property. And then this part is going to kind of help your brain see why this works on the distribute out sort of situation. And so I had mentioned earlier that distributing out is similar to reducing fractions. You find a number that can divide evenly into both of the numbers in the term. 4 divides evenly into both of them. And so I would divide that out of there. Divide by 4 to both terms. Be fair. And 4 is going to end up on the outside because that's what I divided by. 4 divided by 4 is 1x, or just x. It's the same as saying 1x. And 8 divided by a positive 8 divided by 4 is going to be 2. And so there's the distribute out. This explore activity helps your brain see what's going on there. Why does that work? So if you've not seen algebra tiles before, these are x's. These long bars are considered x, and the short ones are considered 1 unit. Okay, so if I have to factor 4x plus 8, I'm going to model the expression with algebra tiles. These are x's and these are 1s. So I would use 4 positive x tiles. Oh, let me put a color you can see. And then I would use 8 of the 1 tiles. So I'm going to use yellow. I hope it shows up. Oh, yes, it does. 1, 2, 3, 4 of the X tiles. Those long bar tiles are for the X's. And then I'm going to do 8 of the 1 tiles. There they are. And what you would want to do is arrange the tiles to form a rectangle or square, the total area representing 4x plus 8. So I'm going to rearrange them so that my 4 bars, my 4 x's are there. Then I'm going to take those 8 ones and kind of line them up underneath there. 1, 2, 3, 4, 5, 6, 7, 8. And so this is still 4x put together with positive 8. And remember when we were working on area, right? It's this, everything inside is the length times the width, right? So we're going to take the same idea. What is the length of this square here, or this rectangle? It's 1x plus 2 of the 1s, right? So x plus 2, 1x plus 2, right? And what is the width of it? Well, it's the width 1, 2, 3, 4 of the ones. So I would be taking the 4 ones and multiplying it, because that's the length and the width. So I multiply the length times the width. I take these 4 ones, multiply it times the x plus 2 on this side, and that is the area of this with the algebra tiles. Take a look. So that was just your brain's way of seeing what's going on there. They're talking really about, lining those up as an area. This explained it here. So the width is 2 tiles, one, 2 of the positive 1 tiles, or 2. Sorry, that's not right. 4. And then the length is 1x tile, and this is where the 2 are at, the 2 of the 1 tiles, or x plus 2. So I would do this times that, 4 times x plus 2, to get the distributed out version. So this is what's going on that. It would take some practice to understand these algebra tiles, but understanding the basics of the algebra tiles definitely will help your brain as you move further into math, because your brain learns to build that modeling on top of it when it gets even more complex. So give these a try with the algebra tiles, and but also be familiar with how to distribute out. This is the way you could do it mathematically. You don't always need the tiles, but it's good for your brain to see what's going on there.